Hello friends, today we are going to discuss an important beat of the unit number 4, and that is nothing but depreciation. The unit number 4 is all about the economic analysis of the power plant, and depreciation is one of the important beats in this unit. Depreciation is the most important item in the fixed cost, and it represents the reduction in the value of the equipment and other property of the power plant every year due to continuous wear and tear, and also due to obsolescence. The first factor can be reduced by proper maintenance of the equipment and the building, but the second factor, obsolescence, is quite unpredictable. To account for the depreciation, a certain fixed amount is set aside every year, so that by the time the lifespan of the plant is over, the total amount accumulated equal the replacement cost, that is original cost of the equipment less than expected salvage value. The methods which are used commonly to determine annual depreciation charges are straight line method, diminishing value method, and sinking fund method. Now, one by one, we are going to discuss what are these methods. The first method is a straight line method. Here in this method, it is assumed that certain depreciation occurs according to the straight line law, and therefore in this method a constant depreciation charge is made every year on the basis of total depreciation. It means initial cost minus scrap or the salvage value and useful life of the equipment or property. The annual depreciation charge is mathematically denoted by following formula: initial cost minus salvage cost to the number of years of useful life. The initial cost is denoted by letter P, salvage value is denoted by letter S, and number of years of the useful life denoted by letter N. Though this method is very popular because of its simplicity, but it does not take into account the amount of interest earned by the amount set aside yearly. The assumption of constant depreciation every year is also not correct, and that's why many times we are not applying the straight line methods. This straight line method is graphically illustrated over here. The figure is provided in front of us, which represents the straight line method of determining depreciation. On x-axis we can see the timing in a years, while the values we can see on the y-axis, which is represented by the letter amount. In this diagram, the straight line going to represent the depreciation, and as we are looking towards this particular figure, we will come to know that at the initial stage depreciation is very less, but as time going to be increased, depreciation is going to be get increased. Now we will see what is the second method to determine the depreciation. The second method to determine depreciation is diminishing value or decline balance method. In this method, provision is made for setting each year a fixed rate, means rate is fixed during this particular method, first applied to the original cost and then to the diminishing value. such rate depending upon useful life of the plant. This method results in a distribution of total expenses on the plant over its total useful life, because in this method depreciation charges are heavy in early years when maintenance charges are low, and depreciation charges are low in the late years when maintenance charges are heavy. The serious drawback of this method is that a heavy burden towards depreciation charges is imposed in the early years when the plant is to develop and build up its income. In this method also, the amount of interest earned by the reserve accumulation is ignored like a straight line method. Now we will see in depth what is the diminishing value or decline balance method. Let the capital cost of the plant be P, salvage value after useful life of equipment on n years be S, and annual unit depreciation is denoted by letter X. The value of the plant after 1 year is P multiplied by in bracket 1 minus X. The value of the plant after 2 years will be P in bracket 1 minus X multiplied by in bracket 1 minus X. It means it will be P in bracket 1 minus X square. The value after n years will be S is equal to P in bracket 1 minus X raised to X bracket complete raised to n, or 1 minus X is equal to S divided by P bracket complete raised to 1 divided by n. It means 1 minus X we have kept at the left hand side, and remaining all terms we had put in a right hand side. In the same fashion, if we will go and do the further calculation, X is equal to 1 minus S divided by P bracket complete raised to 1 minus n. The deposit to be made at the end of first year of completion of the plant. So here we can multiply this whole equation by P. So X multiplied by P is nothing but P multiplied by 1 minus S divided by P bracket complete raised to 1 divided by n. Deposit to be made at the end of second year of the that completion of the plant is nothing but X into 1 minus X into P. It means it will be X minus X into XP. So here we can rewrite this equation as P into S divided by P bracket complete raised to 1 minus n into P in bracket 1 minus S divided by P bracket complete raised to 1 divided by n, and so on. Here this depreciation method is represented with the help of the graph in front of us. The diminishing value method of determining the depreciation is presented by the simple graph, where we can see the time in the years is represented on x-axis and amount of depreciation has been mentioned on the y-axis like the straight line method only. But here the depreciation is denoted, depreciation is marked with the help of the curve, and that curve we can see in the diminishing value method of determining the depreciation.